Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. In this video, I would like to explaining in details about a measurement standard. So basically that will be the line standard, end standard, wavelength standards. So let us start with the basics about the measurement standards. So let's start with the definition of the standard. So basically that will be defined as something that is set up and established by authority as a rule for the measure of the quantity, weight, extent, value or quality. So basically by some authority that will be set up the rules for the measurement. So that will be known as a standard. So basically in terms of the engineering field, there will be the different length standard, angular standards are there. So that will be help into the production of the things as well as into the measurement. So that all known as a measurement standard. Then after the basic role of the standards, how it will be helpful in the field of engineering. So let's see. It gives to support the systems which makes measurement possible throughout the world. So due to that standardizations, it will be having a good interchangeability. So due to that standardizations as well as facilitate with interchangeability. So nowadays at a global market, all the components that will be manufacturing of a single machines with different locations. So due to that standardizations and interchangeability, that all the components were manufacturing at different locations, different countries. Then after, it will be assembled into a single location. So that will be only feasible with the application of the standardizations, or you can say that will be only feasible by the adoptions of the standards into the measurement and productions. So nowadays most of the industries, it will be focusing onto the mass productions, because that will be the lots of demand by the customers, and industries it will be only manufacturing such kind of things at your mass production level only with the help of that standardizations as well as the interchangeability. So due to that standardization and interchangeability, it will be easily assembles or different components that will be manufacturing at different locations by different organizations, and it will be easily assembles and it will be work for the customers. So that will be the basic role of the standards in the field of the measurement as well as in the field of the production. Then after, just you can concentrate types of measurement standards. So first one, it will be the line standard. So basically in case of the line standard, it is measured as a distance between the centers of the two lines. It is also known as a line standards, and basically the imperial standards as a yard and international prototype meter are the basically line standard. So most common example of that particularly line standard, it will be your steel rule. So just you can see into that particularly figure. So this steel rule that will be help for use as a line standard. So just you can see as a line standard when length is measured as a distance between the two centers of two engraved lines. So due to that engraves, or you can say numbers onto that steel rule, so you should take a direct reading from that rule. So that will be known as a line standard. Second one, end standard. So when the length is measured as a distance between two flat parallel faces, so that will be known as a end standard. So the basic examples of that end standards, you can see that will be the slip gauges. It will be considering as a example of end standard. Or you can say that will be the end bars, or you can say end of the micrometer anvils, vernier calipers. It will be also considering as a end standards. Then third one, that will be the wavelength standard. So basically in case of the wavelength standard, just you can see this is the figure So in case of the wavelength standards, basically the 11 general conferences of the weights and the measures held into the Paris in 1960s, and that are defining that the meters as equal to the 1650763.73 wavelengths of the red orange. So particularly these portions, and the red orange radiations of the krypton isotopes, that will be the 86 gas. So just you can see into the figure. So what happens, that particular committee, it will be into the Paris, that are decided to recommend that krypton 86 was the most suitable elements, and that is should be used into a hot cathode discharge lamp that will be maintaining at around a temperature 63 Kelvin, and these standards made the primary unit accessible to any laboratory and reduce its uncertainty by a factor of the 50. So just you can see that will be the different rays: gamma rays, X-rays, ultraviolet rays, infrareds, radar, FM, TV, short waves. So as from the requirements of my applications, it should be measured. So basically the standards now define as a reproduce to an accuracy of around 1 part into 10⁹. So just you can see that will be the different ranges, it will be the different color codes. So if you compared with the meter and yard, so generally 1 meter that will be equal to 1650763.73 wavelengths, and if you're talking about the yard, so that will be 0.9144 meter. So just you can see wavelength standard, when the length is measured as a distance between the wavelength of the lights. So that will be the different wavelengths is being available over here, and according to that gamma rays, X-rays and ultraviolet rays, it will be having a differentiated. After this, just you can see the starting with the meter and yard. So just you can concentrate over here. The first one, it will be starting with the meter. So in case of the meter is defined as a 1650763.73, that will be the wavelength as we already discussing, and that will be of orange radiations into the vacuum for the krypton 86 isotopes. But right now just you can concentrate onto that particularly international prototype meter. So that kind of cross sections it will be found onto the meters. So the length of the meters, that will be defined as the straight line distance at generally 0 degree centigrade between the center portion of the pure platinum iridium alloys. So generally around 90% of platinum and 10% of the iridium is being used, and the length around 102 centimeter. And having a cross section, just you can see such kind of shape, or you can say X kind of shape is being developing for that particularly meter standard. So onto that meter, what happens? The upper surface of the web is slightly polished and has two fine lines engraved over it. So the distance between the center portions of the two lines engraved onto that particular polished surface of the bar of the platinum iridium alloys is taken as a 1 meter. So that will be the standards. So what happens? The graduations onto the upper surface of the web, which is coincide with the neutral axis of that particular sections. So that means the distance onto the both the ends. So the shape has the two distincts, and that will be having a one of the advantages. So the neutral axis lies at the top of the web, and therefore whole of it can be graduated. Second things, the section chosen gives the maximum rigidity and the economy of the cost of the materials, and basically the overall width and the depth of these sections are 16 mm each. So just you can see At the top side, that will be the 16 mm, and the height basically that will be also 16 mm. So this is our meter standards, and you can say that the international prototype meter that will be kept by the Bureau International des Poids at generally into the France is being developed. So basic, that will be the advantages of the meter, but for this meter standard it will be also having some of the disadvantages. So these meter standards are generally influenced by the effect of the variations onto the environmental conditions like temperature, it will be effect, humidity, pressure. So change into the lands. So once it will be changed into the land, there will be a difficulties into the measurement, because that will be considering as a meter standard, or you can say that that will be the land standards. Then second things, if these standards accidentally become damaged or sometimes it get destroyed, then extract copy could not be made. So that will be the most difficulties into the workshops. Then the replica of these standards will not be available for use somewhere else. So one more difficulties. Then the conversion factors was to be used for changing over a meter working. So that all are the advantages of the meter. Then some characteristics required as a composition wise, then length wise, and some of the disadvantages. Now we will discussing with a yard. So just you can see into the yard. So yard is defined as a 0.9144 meter, and this is equivalent to the 1509458.35 wavelengths of the same radiations. So if you compare that meter, yard and wavelength, so that will be having some relations are there. So in case of the yard, just you can see that was a empirical yard standards, just you can see, which is made with a bronze. So basically bronze means that will be the copper and tin alloy, and in case of the composition wise, that will be made with the 82% of the copper and 13% of tin, and almost around 5% of the zinc. It will be also added into the chemical compositions of the formation of the yard standard. So the dimension wise, just you can see, there will be having a 1 inch to 1 inch square sections, and it will be having a 38 inch long. So that will be having a standard conditions, or you can say standard dimensions for a yard standard. And if you observe that, that will be around 62 Fahrenheit. So basically in case of the yard standard, a round recess, or you can say 1 inch away from the two ends is cut at the both the ends, and basically into your central plane. So if you observe that, that will be our central plane, and both the ends, that will be the 1/2 inch, that will be the hole. So just you can see, that will be our gold plug indicating by the dark areas. So this a gold plug of the 0.1 inch diameter having the 3 lines engraved transversely and 2 lines that will be longitudinally. So is inserted into these holes so that the lines are into the neutral plane. So yard is then, you can say, defined as the distance between the two central transverse lines of the gold plugs at a 62 Fahrenheit. So just you can see, this is our gold plugs, which will be having a diameter around 1/2 inch, and that will be the 1 yard distance, and around it will be work within a 62.62 degree Fahrenheit. So basically that will be the standard conditions as a temperature 62 Fahrenheit, but keeping that particularly gold plug lines at a neutral axis has some of the advantages. So that will be the important part. So due to that, bending of the beam of the neutral axis remains unaffected. Then the plug being in a well is protected from the accidental damage. So both that particularly disadvantages of the meters that will be overcome into the yard. So if you making a relations with respect to the meter, So 1 yard, that will be equal to 0.9144 meter. So that we already discussing. So that will be the basics about the meter and yard as a standard. Then after, just you can see the basic difference between line standard and end standard. So just you can see the basic difference. So if you work for the line standard, so you should use steel rules. So it will be measure the two center distance. So that will be considering as a length measurement. And if you observed for the diameter measurements, so it will be the measurement distance between the two flat planes. So that will be, you can say it will be the end standard. So in case of the line standard, our measuring scale, it will be usable instrument, and in case of the end standard, it will be our vernier calipers, or you can say slip gauges, that will be also considering as a end standards. Then by theoretically difference between the line standard versus end standard, just you can concentrate by the characteristics wise the principle of the line standard and end standard. So in case of the line standard, the length is measured between the two lines in case of the lines. But in case of the end standards, the length is expressed between the two parallel flat surfaces. So as already we discussing on to that. Then characteristics with the measurement. In case of the line standard, which will be simple and quick, but in case of the end standard, time for the measurement is more. Then third, characteristics wise for the errors. In case of the line standards, the possibility of the parallax error. So generally that will be the reading error. You can say that will be the parallax error. So always your reading, it will be at the right angles. So that will be the most preferred positions to take the readings. But in case of the end standards, it will be generally errors due to the improper ringings effect if you are using the slip gauges, or change into the temperatures. So environment conditions and that particularly ringing effect, that will be applicable, or you can say used for joining of the two slip gauges. Then characteristics wise, talking about accuracy, so up to plus or minus 0.2 mm unless provided with the magnifying glasses onto the line standard. In case of the end standard, plus or minus 0.001 mm. Characteristics wise for manufacture and cost. In case of the line standard, the comparatively simple to manufacture and cheaper, easily available into local markets. But in case of the end standard, complex methods for manufacturing of that particular standards and manufacturing and the higher cost. If it will be the calibrated like a slip gauges, so that will be having a maximum cost. In case of the effect of the use, in case of line standard, end of the scale is subjected to wear. So depends upon the material characteristics. And in case of the end standard, due to the continuous use of the measuring faces get worn out, specially end pieces may be needed. So that all are regarding for the line standard and end standard. Now just you can see the basic difference between metal standards and wavelength standard. So as from the characteristics wise, the effect of the environment. Suppose I am talking about metal standards, so influencing by the variations of the environmental conditions like temperature, pressure, humidity. But in case of the wavelength standard, there will be no any kind of effect by the environment conditions. So that will be makes an advantages of a wavelength standards in case of the environmental effect. Second things, the replacement after the damage. In case of the metal standard, if damaged, exact copies cannot be made. So that will be the difficult task. But in case of the wavelength standard, can be easily reproduced that particularly wavelengths. Third, wear and tear. In case of the metals affected by wear and tear after long period of time, that all that standards it will be weared out. But in case of the wavelength standard, no subjected to wear and tear. So that will be having one more advantages. Availability of the replicas. For the metal standard, exact replicas are not available elsewhere. But in case of the wavelength standard, identical copies can be kept in all the standard laboratories. And final one, availability of the replicas. So in case of the particularly metal standards, required to be preserved, or you can say stored under the strict surveillance to prevent damage or destructions. But in case of the wavelength standard, no such security requirements for that particularly standards. So I hope you understand this. If you like this, then subscribe and share more the mechanical engineering tutorials. Thank you so much and keep watching.